What we're going to do today is we're going to find the point of the lightning strike. Now, the points that we are given are, we have weather station A. Now, weather station A is located at 3528. And then we also have weather station B, which is located at 5212. Now, the other point that we are actually given, the other piece of information, is the slope of these lines in comparison to where the lightning strike is. We don't know the point of the lightning strike, but that's what we're going to find out. And we're going to use the system of equations to do this. We're going to do a couple things. So the slope of this weather station's line in comparison to the lightning strike, we're going to use slope being represented by m, which is negative 1.732. Then weather stations B, its slope is what is it?
0.577.
77? Okay. So what we are going to do is we're going to solve by using slope-intercept form. We're going to solve these two equations. So we're going to set them both up in slope-intercept form, which is y equals mx plus b. And what we're solving for is to find, we want to eventually find out the point of the lightning strike. The lightning strike right there. Okay, so y on this is 28, so 28 equals negative 1.732, then x, which is 35, plus b, which we have no idea what b is. So then to set up this one's formula, it is going to be y, which is 12, equals 0.577 x, which is 52, plus b. Okay, so now we're going to solve these. If someone wants to do this on a calculator for me, what is negative 1.732 times 35?
Negative 60.62.
Negative 60.62. Then we're going to drop all this down, which is equal to 28. Now we're going to add 60.62 to each side. 60.62. This is going to cancel out, and we are going to be left with 88.62, which equals B. So there's that. We've got B for that one. Now, if someone wants to multiply 52 by 0.577.
It's 30.004.
30.004 plus B. Now that equals 12. So now we're going to get B by itself. So we're going to subtract 30.004. 30.004. Should be able to do that in my head, but I didn't. And it's
Negative
28.
Negative 18.004.
So negative 18.004 equals B. Okay, so now we've just given ourselves a new point that we get to know to now set up a system of equations to find out the x and y coordinates of the lightning strike. So once again, we are going to use slope-intercept form, and the new point that we have given ourselves is where this line, like these lines hit the y-intercept. So these lines hit the y-intercept at negative 18.004, and this one hits it at 88.62. Now these lines are both in comparison to the lightning strike. So we know that if we use these two equations, we can actually find where they intersect at. So we're going to find that system and find these two coordinates. Does that make sense?
Yep.
Yeah? Okay. Alright, so now y equals mx plus b. So we don't know what x and y are, but we do know what slope is and we do know what the b is. So we have y equals negative 1.732 x plus b, which is 88.62. Now on this one, we've got the same thing. We don't know what x and y are of the lightning strike, but we do know the slope and b. So we don't know y equals m, which is 0.577 x, then plus b, which is a negative 18.004. But bam, so now what we're going to do is actually set these two equal to each other because they're going to have the same y point. So there's no reason that we can't set these two equations equal to each other. So we have negative 1.732x plus 88.62 is equal to 0.577x minus 18.004, and we're going to solve for x. So the first thing we're going to do is move this little guy over. Which equals what?
106.624.
And then we're going to actually move this one over here. So we're going to get rid of all the negatives in this equation. 3, 2x. That is going to cancel out. Then plus 1.732x, which equals what?
2.309.
2.309. Okay, so now we still need to get x by itself. Bam, divide by 2.309, divide by 2.309, and we are going to be left with whatever this is equal to. That is our x coordinate.
So 46.1776.
That's x. So there we go. X is 46.1776. Good Lord. Okay. Now that we have x, we're still going to keep, well, what we can do is we can either keep them equal to each other, but that's really, it's not going to do anything. So we're going to plug x in for this equation and find out what y is. So y is going to be equal to whatever this is, and it should be, there's x in there, it should be the same on this side. So we're going to do negative 1.732 times 46.1776, which is 81.
Negative 79.9796.
One more time, negative 79.9.
796.
796. Okay, and then plus 88.62.
So it's going to be a positive 8.6404.
6404. So there we go. This is what y equals in this equation, and it's, almost likely that it's going to be the same for both. So just to double check it, let's plug x into this one. So 577 times x, which is 46.1776.
That's 26.6445.
Okay, then we want to subtract that number by 18.004. So we want to subtract that. Then we will have our y. Which, by the looks of it,
Is 8.6404.
There we go. So there are our coordinates of the dangerous little lightning strike. There you go.
Good job, Kimberly.